Hello. In this video, we'll speak about the basic elements of communication. This is communication in physics. So elements such as the sender, the ideas, encoding, communication, channel, receiver, decoding, feedback. See the sender. You can read about all of these elements. As example, the sender, the person who approaches our services with the intention of getting an answer to his or her questions or passing a feedback. The ideas, the past ideas are the subject matter of this action. These can represent attitudes, opinions, views, feelings, suggestions, complaints, or questions. Encoding represents the conversion of subject matter in certain symbols. Here things get complicated because most people use their own definition for certain emotions or ideas. The way they put this in sentences offers a view over their type of personality. And number 4, communication is channel. The 5, receiver. 6, decoding, and 7, feedback. Here are study some methods of propagation of EM. EM stands for electronic microwaves. This EM or electronic microwaves, as we see in the picture, we have 3 layers of atmosphere. The nearest one is the troposphere, which is about 0 to 12 kilometers from the surface of Earth. The second layer is the stratosphere. It's away more than 12 kilometers and less than 50 kilometers. And the third layer, mesosphere, from 50 till 80 kilometers, and the thermosphere more than 80 kilometers. These layers are used as mirrors for transmission or communication of electromagnetic waves. Here we have different types of transmission or communication. The first type is the ground wave, the second is the sky wave, and the third is the space wave. And we have some laws, we can discuss it, and we have another example at the end of this video. So let's start with the ground wave. The ground wave used for low frequency range transmission, mostly less than 1 megahertz. This type of propagation implies the use of large antennas, order of which is equivalent to the wavelength of the waves, and uses the ground or troposphere for its propagation. Troposphere layer, the first layer, as we see this first layer, which is far from the Earth by 12 kilometers. For its propagation, signals over large distances are not sent using this method. It causes severe attenuation, which increases with increased frequency of the waves. Sky wave, used for the propagation of EM electromagnetic waves with a frequency range from 3 till 30 megahertz, make use of this ionosphere, so called due to presence of charged ions in the region of about 60 to 300 kilometers from the Earth's surface. These ions provide a reflecting medium to the radio or communication waves within a particular frequency range. We use this property of the ionosphere for long distance transmission of the waves without much attenuation and loss of signal strength. Another important point to note is the consideration of the angle of the emission of these waves from the ground. The transmitter emits the EM waves at a critical angle to ensure total reflection to the ground, just like the total internal reflection of optics waves. Otherwise, the waves may escape into space. Escape distance is the distance between the 2 points between which the wave transmission happens. So, as example, we have here, this is the ionosphere. It work as a mirror, and we have here the transmitter. This is the tower of transmitter, and which is sending the signals, and here the signals are moving in this direction, and when it's meet this surface, it will reflect to this direction. Here we have the receivers which receive the signals. Okay, so this is the escape distance from the transmitter to the receiver, and here the escape zone where the reflection happened. Space wave. The third type of communication or transmission is the space wave. We use the space satellite. It's not satellite, maybe some kind of or less than satellite. Used for a line or side communication. It's here no reflection. The waves is working or traveling in a straight line, as you see. This is straight line. Okay. I can move here the video. Line of sight communication, so it's also called LOS, space satellite communication, and very high frequency waves uses propagation method. It basically involves sending a signal in a straight line from the transmitter to the receiver. We must ensure that for every large distances, the height of the tower used for transmission is high enough to prevent waves from touching the earth. So to prevent something like this, for avoiding attenuation or decay of the barrier. There is a very important relationship for determining the height of the antennas and their corresponding distance of transmission given by this equation, where dm is the distance between two antennas, the sender and receiver, r, which is the radius of earth, which is equals 6040 kilometers, and ht, the height of transmission antenna, hr, height of receiver antenna. يبقى HT الهايت اوف ترانسميتر، عشان كده T HR الهايت اوف ريسيفر. Also very important to note is another important relationship determining the range of transmission DT. Range, which is approximately for a given antenna of height HT, which is equal root mean square of 2 times radius of earth times the HT height of the transmission antenna. Thus, we have reached the end of this discussion, wherein we have seen and studied about the electromagnetic waves, understood the concept of their production, and studied their properties. I think I don't cover this in this video, but you have studied already, read about the how to produce electromagnetic waves and how what are its properties, like the frequency and the time period and lambda, which is the wavelength. We also looked at various types of EM waves available, their utilization, and studied the method of their propagation. Also, knowledge of these concepts and types of electromagnetic waves will help the reader understand their complex limitations and applications. Solved example: find the transmission range for an antenna of height 100 meter. So we know the range of transmission for an antenna is distance equals 2 times the radius of earth times the height of the antenna under the root mean square. We have to calculate the root mean square of 2 times r times ht, where r equals 6,400 kilometers and the height equals 0.1 kilometer. All dimensions will be in one dimension, which is the kilometer. Then substitute in the equation above. So by multiplication we found 35.77 meter, no, kilometer. Here is some mistake. Instead of meter, kilometer. Thanks for watching. If you like this video, please subscribe to the channel, share it with other colleagues, and write a good comment to support us to continue.